Hello everyone, myself Ajay. I am first year undergraduate student of IIT Roorkee. My branch is Data Science and Artificial Intelligence. Today I am going to explain the conversion of decimal number to its binary form in the case of positive integers. Positive fractions could also be converted to binary form, but I am going to explain only in the case of positive integers. So let us start. Let us first introduce ourselves to number systems. Now, decimal number system. It is a number system which uses digits from 0 to 9 to represent a number with base 10. Means we can use all the numbers from 0 to 9. So 0, 1, 2, so on 9. And we can write the number. Whereas in binary number system, we should use only two digits. They are 0 and 1. And they are represented with base 2. So example for decimal number system is 309, 309.65. Like that. And for binary number system is 10, 101 and 101.01. Means we are using only 0 and 1 in binary system and all the digits from 0 to 9 in decimal system. So this is our number system. Let us discuss some important points about binary number system. Computers use binary number system to process data because binary number system it helps the computers to identify the errors and fix them easily. So binary number system is used in computers, and learning the conversion of decimal to binary system is useful in programming and for electronics. So these are some uses. So now let us discuss the process of converting the decimal number to its binary form. First of all, we take any decimal number which must be a positive integer. We divide the decimal number with 2. So you will be getting quotient and remainder. Now you will get the remainders as 0 or 1. So note the remainders we are getting aside. Then divide the quotient obtained again with 2. So you must be repeating this process until the quotient becomes 0. So you will be doing repeated division with 2 until the quotient becomes 0. Then the binary form of the number is obtained by reading the remainders in reverse order. So if you are getting remainders in order as 1 0 0 1 1, then the binary form of the number becomes 1 1 0 0 1. So this is the process. We will further understand it clearly by through an example. So let me give now an example. So now let us understand the conversion clearly through an example. I am taking 51 as the decimal number. So step 1 is divide decimal number 51 with 2. So after dividing decimal number 51 with 2, I will get quotient as 25 and remainder as 1. So divide again 25 with 2. So and you will get quotient as 12 and remainder as 1. So you should continue this process until you get quotient as 0. Now the binary form of 51 is given by reading the remainders in reverse order. It is nothing but in this order. So reading the numbers remainder from down to up, we will get the binary form of the number. So binary form of 51 is 111001. So this is the binary form. Now we will understand the logic before writing the code. Now let us understand the logic before writing the code. I am taking the decimal number as n. Dividing the number with 2 gives me n by 2. And remainder after dividing with 2 is denoted by n modulus 2. So note that aside. Then repeated division is done with 2 until the quotient becomes 0. So this is the process we have seen through an example. Now, from in above example, we have seen that binary form of 51 is equal to 110011. So this is the binary form, which could also be written as 1 in 10 power 5 plus 1 in 10 power 4 plus 0 into 10 power 6 plus 0 into 10 square plus 1 into 10 power 1 plus 1 into 10 power 0. So this is the digit in unit place. It is multiplied with 10 power 0. From our example, we have learned that we are reading the remainders from down to up order, which means the first remainder. The first remainder is multiplied with 10 power 0. And then The successive remainder is multiplied with 10 power 1, and then we are increasing the powers of 10 until we obtain the last remainder, and we are adding all of them to obtain the binary form of the number. So this is the logic. Now I'm going to write a pseudocode for this. So now let us write the pseudocode for this conversion. I am taking a variable number whose data type is int and another variable sum whose data type is also int, and I'm initializing this to 0. I'm taking another variable whose data type is also int, it is power, and I'm initializing this to 1. This is nothing but 10 power 0. From the logic, we have learned that we should keep on increasing the powers of 10 and multiply with the respective remainders in order. I will explain by taking 51 as an example further. Now I am writing a while loop. In while loop, the condition is number must be greater than 0. As we describe the data type of number as int, it is an integer, and greater than 0 implies it is a positive integer. Now I am taking another variable remainder whose data type is int, and it is given by number modulus 2. Okay. Then I am updating the number to number by 2. Then I am taking sum. I am updating the sum to sum plus remainder into power. So while running the loop for the first time, the sum is we have initialized the sum to 0. So this would be 0 for the first time. So this is 0. Then and plus remainder into power. So remainder is obtained from this one. So remainder is this, and and power, we have initialized power as 1. So initially the power would be 1. So this one, and then power, we have updated the power to power into 10. So this power gets updated to power into 10. Here initial the power is 1, so it is 1 into 10 and it is 10, and it quits the loop. Then we will further, and if the number is still greater than 0, it will run the loop continuously until the quotient becomes 0. So let us take 51 as an example. I am taking 51 in the place of number. So my number is 51. Yes. So I am initializing sum to 0 and power to 1. So in number is greater than 0. As we know that 51 is greater than 0. So this loop runs. So remainder is equal to number modulus 2. So 51 modulus 2, we will get the remainder as 1. So it would be 1. Then number is updated to number by 2. So 51 by 2. As we have described the data type of number as int. So 51 by 2 would become 25 because it would take only the integer part. So this becomes 25. Then sum is equal to sum plus remainder into power. Here initial the sum is 0 plus remainder we have obtained as 1 from here, and power is we have initialized as 1. So it would be 1 into 1, and then further power updates to 1 into 10. It would be 10, and it quits the loop. So again we have got the sum as 1 from here. Then again my number has updated to 25. As 25 is greater than 0, the loop runs again, and remainder becomes 25 modulus 2, which is also equal to 1. Then number gets updated to number by 2, which is 25 by 2. We will get the integer part as 12, so number will get updated to 12. And sum, initially from while running the loop for first time, we have got the sum as 1, so it will be initialized in this case. So sum would be updated to sum plus remainder in power. Here initially the sum becomes 1. So this is 1. So this becomes 1 now, and we have obtained the remainder as 1 again, so it would also be 1. Now after running the loop for first time, the power has been updated to 10, so it will be 10 now. this is 10. So the sum becomes 1 plus 10. And the power again gets updated to power into 10. As the power is 10 here, it gets updated to 100. And again it quits the loop. And we have obtained here number as 12. So by updation, we have obtained number as 12. Then again it checks in this loop. So number 12 is greater than 0. Again it runs and it runs and runs up to when we obtain the quotient as 0. So when quotient is 0, the number becomes 0. So this contradicts this statement. So the loop automatically stops and we will get the output sum, which we have learned from the logic. So this is now I am going. I have written the code which I explained in the pseudocode earlier. So I have added extra two lines here. This is nothing. I am asking the user to give input of the number. So now let us run the code and check whether if it runs or not. So running the code. So I am typing 51. Check. So you can see this. You can see the result. This is the number we have obtained before in the regular explanation. So I will type another number. So I am giving the input as 45, and you could see the binary form of the number. So we have run the code successfully. Thank you.